Hi Amos. Hi Shwanish. Are you guys able to hear me? Okay, cool. So we'll wait for. We'll start exactly at 9:05. Still 1 minute uh, before 9 o'clock in India. This is 9 p.m. in India. We'll start in another 3 minutes. Hello everybody. We'll wait for another 2 minutes and then we'll start. Hopefully you guys are able to see my screen. So, uh, hello for the people who are directly watching either on the fifth IR or on the YouTube. So, hello everybody. We'll wait for another 1 minute and then we'll start. Look for more people to join. Bhaskar, I am loud and clear, right?
Yeah, Anjani, very much.
Okay, cool. So, yeah, so I think we should start. Uh, so, hello everybody. As like most of our usual session happens on Sunday, but this like there are few sessions that happen often on Saturday, uh, and this is one of it. And like we got a very like Bhaskar had a very busy schedule out of company, as you know, he has startups and then from his own research work, but we got some time from him after such a long period of gap, long gap I would say. And thank you Bhaskar for giving your uh, hour today. So today's session is like there are a couple of multiple questions that were there that used to come to us, and the people who are mostly asking about, I'm doing research, I'm a data science expert, I do a lot of data science experiments, but how do I apply actually and exactly into the real industry problem? How do I apply into the use cases which are prevalent in the market and that actually works for, like that brings money, or that actually brings value to whatever I do in terms of either client benefit, or the project that I am working is actually gaining something out of it. And there actually engineering comes into the picture, and therefore this session we tried building and structuring in a way that we make sure that we actually uh, take out the gap which is currently there at this point of time between the research and engineering through this short session which Bhaskar is going to give. So the session highlight, as you can see, is like the topic is scientific computing best practices on cloud for data scientists and research, and therefore we have said cloud, that so that if you're engaging cloud, if you're doing, if you're trying to implement your data science practices on the cloud, there are multiple things that comes into the picture, and how can you tackle it very well and in a more usable way. So the session highlight is what is scientific computing, how is it distinct from other aspects of ML, machine learning, how to build a distinguishable stack of your data science skills, what is auto ML and automatic feature engineering, and Bhaskar will obviously share some live examples and case studies, trending scientific Python libraries for data science scientists, underrated but useful tools for data science engineers, the rise of data pipeline and post COVID-19 models, free resources, handy cheat sheet, self-paced PDF guide, code snippet, etc. And there is obviously a certificate um, attached with it, but but there may be some admin charges, very minor admin charges, which is needed even for our team to make sure that we keep on delivering the best from the technology enablement perspective, which is running in the background to enable this tools and session. So if I talk about Bhaskar, Bhaskar is a co-founder and is a principal data scientist at multi-cloud for you. He lead the data science and AI team at multi-cloud for you. He is ex-publicist. He has 15 plus years of industry and research experience. He has 2 US patent, and he is a AI practitioner. I mean to say that he is a practical AI practitioner, and he know how to get that implemented into real business scenarios. Bhaskar Tripathi can be connected on his LinkedIn profile here, and he's a PhD scholar. He's um, currently almost near to complete his PhD degree. I am Anjani Kumar. I am inventor, leader, mentor, founder, enabler. I have multi decades of direct service to the IT industry. I am ex-publicist, RBS, Microsoft. I am the chief evangelist of multi-cloud for you, and I am a chief architect of multi-cloud for you as well. And this is my LinkedIn profile. You can connect to me directly anytime. If I talk about multi-cloud for you, many of you know is like we primarily stand for evangelism and community, and obviously to support that up, uh, uh, we, uh, we try to fairly connect, sit between, or fairly build a bridge between corporate and startup. We try to bring out real engineers out of their bunker. Mean to say that I've already said multiple times. It's mean to say that we try to find out the engineers who can tell their stories out to the world, their experience, right from uh, the battle scenario. Guide the engineering community. We do consultancy, community, product, and research, and we are primarily based and expert in the data science world. With a multi-cloud, extensive experience in multi-cloud and high extreme engineering. Obviously, we do blockchain, we do data science and AI, multi-cloud strategy. Certificate, recording, and content for this session is always available on. You just have to search 5th IR plus Bhaskar, and you will find all his courses and session on 5th IR, which is our evangelist platform. 5th IR is a SaaS-based self-service platform. It connects technologies from a startup and corporate. It is like we have built the platform, and we are already researching on the platform to bring it out in a way that it becomes a transitional support to 5th IR. 5th IR means 5th industrial revolution, which is which is in terms, it's a complete subject out of it. We'll sometime put a session on it. So we have another session yesterday, which is customer data platform or data engineers, and that brings the hint for this month's session. We'll announce the next month's session again. This is the best practices for data science on cloud, which is given by Bhaskar Tripathi, and then tomorrow we have customer data platform for data engineers by Anand. You guys can join at the same time. I have my with me Bhaskar Tripathi, Rick Kujera, who is the co-founder of the company, and he runs the company from UK. Dheeraj Singh is the co-founder of the company, he runs the company from USA. Uh, Instruction for the session. Obviously, I think everyone is smart enough, and we are much mature community now. Please mute yourself in the convenience of everyone. Type in all your question in the chat box. We'll read and answer all question. During the Q&A, you may ask your queries using your mic, webcam, and chat. So I would give it back to Bhaskar.
Thanks, Anjani. Just let me share my screen. So hi everyone, welcome to today's session at Multi-Cloud for You. This session we are especially conducting for the beginners in data science, the experienced data scientists, basically catering everyone who is associated to data engineering and data science. And then by the end of the session you'll be familiar how to carve out a niche skill set which would be probably to my mind in demand within the next 4 years or maybe 5 years down the line, the way data science is evolving. So let's start with analyzing the market scenario. In terms of the job market, how the data science market is positioned as of now. So according to the U.S. Bureau of Labor Statistics, in late 2017, they released a report where it was said that around 2026, by 2026, there will be around 10 million data science jobs. That itself was a big statement, right? But if we analyze that statement, in its entirety, then data science is a very vaguely used term, right? So typically in a corporate setting, if you have a data science project, you'll have it cannot run in isolation. So you'll have a machine learning engineer or a deep learning engineer who will actually build and create the models. Then you'll have your ETL guys, probably who are pulling the data from the data lakes, data sources, and various other channels. And then there will be sometimes there are front end engineers who work on different visualizations, and then middle tier having work in uh, Scala, or you can say probably different languages like React, and basically catering to the services of the web and mobility, right? And then finally you'll have product managers working with them. So when this report was released, the breakdown, which not really many people go into, actually mentioned that it will be a host of people who will be associated with the data sciences. So these are all data scientists, typically as per the report, but not all of them are actually building the models, right? So in a way, the demand and the supply gap is not as it looks from the report. Although there is a very positive news which Gartner released last year, that the overall spending, IT spending, has been increasing, I think multiple folds since 2019, and during the COVID even more so. So this report was Gartner report was released before 2020, the COVID scenario which really happened and changed the overall ecosystem. But I think since then, probably what we have noticed, is that the IT spending has increased. Everybody wants to go digital. Everybody, wants to play with data, make most use of the data, use AI, use data engineering in all their processes, automate everything. So yeah, that way it looks very promising. And I think that's like one important takeaway, that yes, the good part is that overall IT spending is definitely increasing, and 2021 and probably the next year as well is certainly going to witness increased spending, which means the increased demand as per what was there predicted in the Gartner report. So, with this, there is one caveat, as I mentioned, that, typically for a ML engineer who is supposed to build models, right? And there are many students who have, enrolled for different university courses which teach you supervised learning, unsupervised learning, and so on and so forth. So one of the things to take away from all these things is that there are a lot of ML engineers coming out from the educational institutes, from the online content, and testing, and host of other services which provide education on data science. But not all of them probably would be building models. So the people who are building models, the demand for those people, I'll just talk about in the next few slides. There are some interesting questions probably which we need to pose to ourselves. And it's not just for the industry, it's also for the academia and the researchers who are, working on the cutting edge research. So if you remember, what happened 10 years back when there was a big data buzz. Now it is a skill set. Big data is a skill set which I think probably every ETL engineer at a senior level is expected to have, right? It's no longer a distinctive competency as it was 10 years back, right? So there is a question, when we talk about data science, what is going to happen a decade later? Data science would be a skill which, at least the basics, everybody needs to know. Everybody who is working on the data science in the data engineering world, they need to understand the basics at least, right? So that they can collaborate, they can productionize, and they can deploy various artificial intelligence based applications. It will be hard to survive in that decade. Probably the next decade, or even a decade would be more than what I'm saying. It would be just the next 4 years, 5 years, right? The way it is growing exponentially. So basically, there is a need to assess the demand versus the supply. And I think the supply at this point of time, the way things are moving, it is definitely going to, churn out in a much larger, way than the demand for it actually exists. So, what will be the distinctive competencies 2 years, 3 years hence? I think this is something which we need to analyze, and there are things like 2 years down the line. So today we have a huge demand for data scientists, but 2 years, 3 years down the line, do they start getting fired? Or the auto ML models which perform partly the activities of a data scientist, will they kind of take away certain tasks of your job? So what are the sustainable skills in this area, and how do I build them? So this is something which probably we need to do a reality check. And post COVID, the industry is getting matured. There is a focus on cost saving because of the billions and trillions of dollars that the entire world has lost in this situation. So, which brings us to analyze the time versus expectations, in the data science world, and what is going to happen typically in a, new technology which had come up and which is going and to enter a plateau. So typically, I think on the rise, which is actually the technology trigger that has already passed. Now we are, kind of at the peak of inflated expectations. Every organization, every second or third organization, they want to, use AI. They want to make use of ML, but they probably do not know how to use the data that is already existing with them on their on-prem, on their, native clouds, on the public clouds. How do you marry all the data and make proper use? So, with this, I think probably there is some kind of, disillusionment that, this is a bubble which is going to, burst at certain point of time. So these are all, speculations which we do not know and do not understand at this point of time, and nobody has, solutions of silver bullets which would help people to, measure or create a very effective roadmap. But yes, there are certain skills which if you develop, then probably that is going to help you in the future. So one such skill, or rather, it's a subject area or entire field in itself, I would say, which has definitely has a steep learning curve, but which will definitely be sustainable, is scientific computing. So when I say scientific computing, it includes your domain knowledge. It includes, the data science knowledge, typically the machine learning or the, supervised and unsupervised algorithms, your deep learning algorithms. And it also includes, the way you model things mathematically. And I think the primary skill here is not the engineering skill, but the mathematical modeling skill, which I am going to talk about. So when we say scientific computing, so I would say the most relevant and probably the easiest way to put the scientific computing and define it is, you have a problem, and then you have this problem could be any engineering problem, any science based, or even a social sciences problem, economics, or mathematical finance based problem. And then you with that problem you create a mathematical model, which is generally, people from the data science world would be familiar that we have, cost functions, and we define some equations. And then definitely after defining that, we try to make a model which actually caters to our solution. And these models are usually, when we talk about cost functions, so these are generally referred as inexact solutions, which do not give you mostly an exact solution, but since they are iterative and random in nature, So they give you a solution which is very near to the exact solution, and then finally you apply the solution and implement it in the model and then productionize it. So I'll talk more about it,
Generally
just to
referred
make it
as
clear,
inexact
you know,
solution.
what exactly, I should learn in scientific computing, and what is actually scientific computing, what are the things, or maybe the topics which fall under this category. uh, uh, Probably, at this point of time, I'll give you a very high level picture. So this is something where, to my mind, the world will world of data science will lead in the next few years, where you have people with, at this point of time, people are there in scientific computing, but they do not really understand the data engineering, right? So one thing which is definitely a good skill set is to have an intersection of all these skill set, where you master the tools, and probably, in fact, the programming languages of stochastic modeling, numerical analysis, mathematical optimization, which I'll talk what exactly they are. And then you have your basic, skills to execute the and productionize the application, where you do the model integration, you put the model in a consumable way to the user in form of web and mobile applications, and then you take it on the cloud, you do the ETL and the cloud engineering, and you do the DevOps, and finally productionize the model. So these buckets, once they mix these buckets together, then there is definitely a distinguishable stack, which is something which is unique in itself. And I think this is something where the people will be heading in the next few years. Right now, when we talk about full stack developers, it is mostly the data scientists should understand some kind of data engineering. But again, uh, as a practitioner of data science, and coming from a data engineering background in past, I can understand that both skill sets are together. Having both skill sets is kind of difficult, and there has to be a trade-off where you want to specialize. What would be your primary and what would be your secondary skill sets. So let's talk about scientific computing, for which we have this session particularly. So I would say the way I define scientific computing here would be that it's an intersection of primarily three skill sets: mathematical optimization, stochastic modeling, and numerical analysis. And once we have all these skill sets married together, the intersection of all these skill sets is scientific computing, which has its application areas in computational finance, quantum computing, computational physics. Obviously the data science, which is used in the industry and web applications and mobile applications, and then the high performance computing and big data. Um, so talking about mathematical optimization, I think this is something where it's a huge subject in itself, but typically what is primarily used in the models, in the engineering and the research fields are these things. Like in retail, we use a lot of linear and non-linear programming, and sometimes quadratic programming in operations research problems. Things like if you want to optimize routing path in a warehouse in a typical retail setting, you'll use linear and non-linear programming methods. Parameter estimation is something where machine learning engineers would be familiar that uh, they optimize the hyperparameters. So that again falls into the mathematical optimization field. Combinatorial algorithms are which kind of give you throw out different combinations and permutations of a typical parameter setting, where you know you are supposed to choose one of the the best selective basically the parameters among all the algorithms. And then Markov chains are used in the financial world, in especially in the financial engineering and the stock market prediction world. And quantum optimization is obviously used in the scaling of and improving the architecture of the quantum computing, which itself is a research area, but gradually these skills are catching up. Another basic, very basic skill set, which probably every data science engineer should have, is the numerical analysis, which constitutes of majorly the things which are used are polynomial approximation, concepts of linear algebra, uh, numerical solution to ordinary differential equations. And sometimes if you're working with primary data, where you take surveys from different people and then have an qualitative data, so you would use partial differential equations and approximation of eigenvalues and eigenvectors, methods like dimensionality reduction and PCA and LDA and whatnot. So all these typically topics fall under numerical analysis. And then obviously stochastic modeling is something where you have a host of things which run in an iterative process in the random number. I'll cover the stochastic modeling and optimization of mathematical models in detail in the next few slides. But as we cover the details of these slides, right? So there is a question that why really I should learn a scientific computing, really dig down into the scientific computing uh, domain. Is AI and ML not enough to solve the real world problems? And are we not really solving business and engineering problems already with the supervised and deep learning algorithms? Partly yes, but the problem here is that there are scenarios which are sometimes related to the physical world, like experimentation where in mining area or oil extraction, where you really cannot do the experimentation uh, physically, right? So in these cases you need to run what if scenarios, Monte Carlos, and basically the simulations, right? And all those let's say SpaceX is launching a satellite, so they'll do the experimentation and the simulations well before and stabilize those simulations, find out the exact inputs and outputs much before the launch of the satellite, right? So there are some problems which are like too expensive to be solved by the typically deep learning algorithms, because in a typical setting, let's say you are working on a real time retail system where you're developing something for an intelligent assembly line, you do not have enough time to run a deep learning model, which would probably take a week or sometimes more to run depending on the data, right? In these settings, how do you optimize further when the deep learning algorithms have hit a ceiling, they have touched their plateau, right? So these are things where you need to further optimize or take a different approach, right? So these are areas where you need to understand scientific computing, because generally if you're working on deep learning algorithms or GANs, they're kind of a black box. You do not really understand what is going inside them. So how the optimization algorithms work, and how these are actually productionized and improved into a real world usage, that is something which is really going to be in demand, because going forward, I think the way auto ML is progressing, and the way organizations like Google and even Amazon, they have even Uber, they have launched their AutoML frameworks. So in the coming years, as their frameworks evolve, around 70%, 60 to 70% of our typical data scientist job that we are doing today in the industry, that will be already done, by these frameworks, right? you do not need to do automatic feature engine, manual feature engineering or feature selection, or you know typically even unsupervised algorithms. When you're working with a neural network, you don't need to really optimize the weights and all. So part of this is done. Obviously, it cannot do 100% job of replacing a data scientist, but then definitely it will take away 70 to 60 to 70% of your current day work, right? So the additional thing that we need to really understand is something which is the thing of the future and which is much more sustainable, because once the machines start doing this, men must think, right? So let's really talk about what kind of journey we will have in the future. So this is something which is depicting where I got this from Agile Scientific, a very beautiful description where it talks about the computer science, the pure computer science problem, where we just talk about the algorithms, we talk about the problem and the solution, and then we have a host of other things which are software engineering. So at a point of time, both things, as I said, they get married to each other and come out as scientific computing. Now, where do you really chart your journey is a kind of a black box, and there would be different people with different interest areas, and they can take their different own well defined custom journeys, right? So I would probably say that in terms of practicability, you can choose to be a T-shaped individual, you can choose to be a generalist, and you can choose to be an expert. A generalist would have a great width of all the technologies, but he may not specialize in any one of the areas. Whereas, expert who is probably a researcher or a PhD, they would specialize in one area, but they will not probably have that kind of depth. And then there will be, very seasoned practitioners in the industry who will be definitely in demand, and they will be T-shaped individuals. So when we talk about these T-shaped individuals in terms of the data science industry and the data science markets, uh, how do they look like? So I would say the T itself, the horizontal section of the T could be debated how much width you can have, but definitely for scientific commuting, you need to have expertise in one of the areas. These areas could be uh, typically time series forecasting, or the natural language processing, or image classification, ImageNet, and whatnot, right? But then in data engineering, uh, you need to really define till what extent you need to go and basically measure your width of the technologies in terms of the number of technologies that and obviously the individuals which will be in demand is a T-shaped individual. So these cannot work in isolation. You cannot have a I-shaped individual working and just being a generalist, and obviously need to have a deeper sense of scientific computing. Otherwise, in future, definitely the way AutoML frameworks are evolving, it can take you to one level, but probably not at the next level. So with this, I would say how the question automatically comes to our mind is that how do I become a computational scientist who knows the data engineering and who knows the computational sciences as well? So see, sometimes today, and especially during the COVID, when we are all working from home, I've seen there's a kind of a learn to code movement going on the web and internet. Everybody is offering a number of contents right from the universities. The universities have started, offering online programs to the institutes and the other practitioners as well. And then they're offering different type of courses which sometimes do make sense and sometimes do not make enough sense in terms like if I say that I want to do a 3-day course in dentistry, or I want to become a doctor by doing a 15-day course. Obviously, this is something that you cannot learn in 3 days. Computational sciences is something which needs a steep learning curve. That's a given fact. And computational scientists are not essentially really the programmers. They could be mathematical modelers, they could be product managers, who specialize in one area, and they could be definitely the programmers. But overall, the intent is that we are not programmers. If we are, in true sense, if we are saying that we are data scientists, then we need to get things done with code. So code is just a tool for us, and we are here to help. How do we define, you know, application which has to be productionized? And then, when we are not really trying to teach people how to be software engineers, because there are enough of software engineers in the IT world. But what we would say, computational scientists would be computational geoscientists, or computational, mathematical researchers, financial modelers, which do have the depth of the scientific, areas which I just explained in the previous slide. So let me just give you some practical, things which Google is trying to do with AutoML. So here, first of all, what is AutoML? So AutoML is something where you're kind of automating two very very difficult tasks in the current world. In the basically the modeling world. One is hyperparameter tuning, the other is the iterative modeling. And you can say the model selection and the hyperparameter tuning in a very, very wide sense. This may or may not apply to every problem in the world, but essentially this is one of the things which is the focus area of the AutoML frameworks of the present day. So for example, if you see the Google's AutoML vision, they have kind of a problem where you upload all the images. Let's say the image of a handbag, shoe, hat, or any other merchandise that you have for your, e-commerce catalog, and then you train the model. The AutoML vision will basically evaluate the model, and it will do the selection. It will leverage all the human labeling services for the dataset with the unlabeled images, and then it will register and train the best model, which is going to serve the best output and the most exact output, which is in terms of the practicability, which the user is looking for, and then expose the entire thing as an API. So basically, it could be similar thing like where you are trying to forecast something. Let's say the prices of a security. So you do all the feature engineering, all the data transformation, and all the hyperparameter tuning and the model selection within the AutoML framework. And the only thing that you need to worry about is uploading the right data, and rest the model will take care of itself. It will even return the results, and I'll just show you with the help of some tools how exactly it is done, so that it's not just theoretical, we actually dive into the practicalities. So with this, I'll probably try to show you a couple of tools, and obviously the code. One of the frameworks on which I am working, data modeling framework. But before that, I think one good start would be to explore this tool, which is Rapid Miner Studio. Again, you can get educational license or a commercial license. This is a very, very popular tool, and I think many data scientists would already be familiar with this tool. So what do we exactly do here is we design a model where we just put the data, do some drag and drops, clean the model, and basically do all the predictive modeling or even classification tasks just by dragging and dropping all the modeling in this part. And then it also serves you AutoML where let's say you have some data, right? And then you want to predict certain variable. Let's say I do have this data where I would probably want to predict the US dollar exchange rate, right? And with a host of other independent variables. So I do the, you know, all the, target. I basically put the target, and then, I uh, define whether it's a regression problem, it's a classification problem, all my metrics. And then, I would, it would definitely tell me, running the basic feature selection models, whether, the status of particular feature should be left out or it should be included, right? So if you see that, it is just applying pure simple correlations, but then I can have advanced models also. So this is a very, very simple example where it's just using a correlation value. Anything which has a correlation less than 4, it will discard it, right? And then once this is done, then you run a host of models like generalized linear regression model, any deep learning model, and random forest, and so on and so forth. And then you just start running this process, and it will finally show you the, output of all the predictions and the graphs, and which is the best model. So this is something where, this is one product, but I think the way Google is evolving the API, this is very soon going to be a, uh, you can say a very native or very naive product. This is something, another example which I'll show you here. The problem is same, that, I want to predict the stock prices. There are different securities, and I do have the data which is uploaded already by me. And then what I will do is probably define all the models, here, and it will do the automatic feature engineering. So what it will basically do is that, we do have basic tasks like, loading the data, splitting the data in test and train, and your validation sets, and transforming it, scaling the data into different, normalization, standard scaler, robust scaler, and min max scaler, and so on and so forth. And then, so it's just an example how you build a entire feature engineering library, which will do everything: impute the outliers, vectorize the data, apply all the transformation, delete the duplicates, and then you have everything. Finally, you perform, different feature selection methods using supervised learning, using, GANs, using GRNN, or any other, deep learning model. And once you do all this, you simply define what is your data, what are your input data, and what are your problems. How do you really, want to use your data set? So in this particular example, I'm using a particle swarm optimization and a gray wolf optimization algorithm, where, what I am exactly doing is I have created a library of all the swarm based optimizer, which are nothing but random number based methods, which give you the best parameter selection for a typical data setting, where you need to optimize some cost function, and that cost function could be your entire, support vector regression model, or that could be your ANN, or, any deep learning model, and so on and so forth. So basically, what we do here is that we, frame a problem. So again, I'm not going to go into details of how particle swarm optimization works, because we have already conducted some sessions in past about the optimization models. But all I'm trying to highlight here is that, you just call the kind of optimizers that you would want to define. You configure all your models, and then simply, since all these are, the stochastic models, so you just define the number of runs. And then once you run these models, so typically, once you run these models, you'll get the result of all the iterations, right? And once all the iterations are completed, you will have your best C and gamma. In this case, I'm using a support vector regression So you'll get your best hyperparameters by running all these models. And then finally you can easily see the results, and the I'll probably show you one demo where we do get the results of all the models that we run. So this is the timeline. I ran two algorithms. One was Gray Wolf optimizer, the other was particle swarm optimizer, and I do get the root mean square error, where you can see that the Gray Wolf is much more efficient than PSO in this case. In this particular case, it cannot be generalized though, but yeah. So we can see how the iterations have progressed and how the cost function, fitness function has reduced, and what is the execution time. And obviously, if you want to go in more detail, you can see how the iterations and the root mean square errors have moved from the iteration 1 to iteration n, right? So this is a very small example of auto ML, where the framework itself doing everything for you, and you just need to worry about the results and their interpretation. Apart from giving the input data, yeah, you don't even need to transform the data. Just the framework itself will make it ready for the algorithm to be fed in. So this is something which is really going to be in demand, because here, when we talk about a particle swarm optimization, these methods itself run behind the deep learning models. This is just one of the optimization methods. There can be different optimizers, right? So you can apply different concepts like Levy's motion and whatnot, your chaos theory, your logistic maps. So basically, it is all mathematics, that concepts that we have applied here to get a good forecast. And similarly, Google is also trying to develop their own framework. Right now, the focus is primarily on the business applications, especially classification models. But then they are like stabilizing all their operation research frameworks and other frameworks as well. Though they are not at that level where they can be directly used in the production problems, but definitely I think this is something where the world is evolving. So with this, I would just like to go back to our original skill set matrix, where the mathematical optimization and the stochastic modeling, and I'll just talk about the simulation functions also. Then they are like stabilizing modeling, which are probably I can just show you one more example from if I do have MATLAB. Yeah, that's opened. So here, what we are trying to do is we have uh, kind of a simulation which will give us we run that simulation for 30-40 runs. It's initially it's all random, and then finally the series is converging into a it's basically a convex problem where the series is these could be the stock prices which are all around, and then finally the series is converging based on the method that has been applied in the model. And finally, once it converges, it will give you the exact parameters on which you can optimize your deep learning model. And once that model is optimized, it will give you very close solution to the actual prices which will be there in the real world. As you see, the series has already converged to a point of time, and if we wait more, and as the iterations progress, the series will obviously converge. For now, I am just closing this, as these are problems which, generally get solved in typical deep learning setting in a day or a two, or probably more. Sometimes these problems run for months. But then when you apply all these, numerical skills of these three intersections of the, slides that we have spoken about, I think the way you apply this, it can vastly reduce. So this typical problem that I am trying to solve, typically if I run a deep learning model, it runs for around 2 days on a good scalable GPU. But then here it has nearly converged. The same series, the same problem has converged as I talk here, right? So I think this is the power of scientific computing and the optimization problems, the quadratic and the non-linear programming methods. So these are the skill sets which I was trying to highlight. And not every mathematical model you need to learn. There are a host of libraries which I think we'll be just giving out, and the frameworks which are very very popular among the developers, the community, starting with the AutoML frameworks, and also the the cloud frameworks, which are especially Azure Machine Learning Studio, which provides you a drag and drop, as you saw in the RapidMiner tool. It gives you a similar drag and drop version of your machine learning algo on the cloud. And similarly, Alibaba, the Chinese cloud company, they have also launched a very very nice PAI studio, though not as evolved as Azure, but I think that's also coming up very measuring up really nice, and you can solve a lot of problems on that as well.
And adding to that, if I would like to add something, Bhaskar, is like they also have regular competition happening for the college guys or those who are doing research, and they give a lot
Correct.
of grant to the winners. And recently we have seen that there are guys from India who won it by building a auto ML model and just deploying on their cloud platform.
Yeah, yeah,
So
that's
they
right.
even
That's right.
don't need
I
your
think
solution; they just need the design, and you can put it into the India Mumbai data center or whatever, and still like there's a lot of award that keeps on going in the background.
correct. That's right. And even even Azure, they are giving it I think 12-month trial for free. So I think it's just that you just need to be aware of all these topics and the frameworks and the libraries. And it is as simple as using a scikit-learn, right? These are not very complex libraries, but at least if you master, typically, for AutoML, I think I really like two libraries, which is Tpot and H2O. These are very very stable auto ML frameworks, and you can perform a lot of activities using these. I think we'll roll out the cheat sheets here, which cover all the auto ML tools and libraries. But I just wanted to showcase these scientific problems. So another thing which I just wanted to take another example would be the meta heuristic problems, where again you if you normally you're supposed to forecast wind speed, or do some stock price forecasting again, or some kind of prediction problem, or even classification problem. So what you can do here is explore some libraries which are mentioned in our cheat sheets, using the meta heuristic algorithms, where you can where basically these algorithms are evolutionary algorithms. I think genetic algorithm and simulated annealing differential evolution are very very popular already in the industry. But there are a host of other algorithms, bio inspired and the nature inspired algorithms, which are actually coming up with cutting edge research, and shipping out libraries which you can just use and try, right? So I'll just give you one example here. Typically, what we generally have. Um, so this example is kind of explaining where exactly within the machine learning models you apply the concepts of scientific computing methods. So let's say you have a data where you do the extraction and the pre-processing and transformation, right? And then you split your data into train, validation, and test sets. And then finally you apply some feature selection methods and make it ready for feeding into a supervised learning algorithm. Um, Now, typically, or probably a deep learning algorithm. Now, typically, here you can use population based problems which are essentially these algorithms: evolutionary, physics based, and swarm based, and bio inspired algorithms, nature based. All these algorithms, any meta heuristic algorithm, and then train your model here using different modeling methods like perturbation theory, which is a physics based theory. Then you can use some aging guidelines that initially, as the particles converge, the speed increases as the iteration progresses. And then you calculate the fitness in the normal way that most of the deep learning models. And I'm assuming that people here are at least having the basic awareness of data science. If not, then I'll recommend them to see our basic sessions of linear regression and modeling. And
I have already pinged, like people will also get the free certificate from so we are giving certificate in collaboration with Alibaba Cloud, so you can get a free certificate directly after taking our courses, and then giving a short exam there on the site. Apart from it, we
correct.
are also partnering with multiple cloud platforms. There are multiple sessions from Microsoft coming up. Data engineering team, Microsoft data engineering team coming up next month, and we also have the father of data warehouse, Billion One, um, coming next month with his text-based ETL analytics tool that Bhaskar is talking about. If you talk about
Yep.
T-shaped and where data engineering come, most of the work that is going to happen next, where is around understanding unstructured data and processing unstructured data. So that would be another good thing. You can go on our LinkedIn page and find out more.
Correct, correct. Yeah. So essentially, I just trying to highlight that this particular area where we are applying different, theories, these are the ways where we use the scientific computing methods, and this is something which is a skill which will really be in demand in the going years going forward and moving, let's say, 5 years down the line. Um, so this is just an explanation of those methods. The way, how do you proceed to learn and how do you get the resources? I think these are, in my books, these are the best resources. You typically, I think you don't need to go to all of the resources. I think Google Scholar is one resource, and I would say that MDPI journals, also the IEEE journals, and obviously ResearchGate. But these three, along with Google Scholar, I think they can solve your problems because these journals are free and you'll get the best resources. On ResearchGate, you can just ask the author of the research paper. They can just give you those research works for free. You can just request them for a download. So all those are which are $50 or $500 or $30 research paper. You can all get that on ResearchGate for free. And on MDPI and IEEE journals, there are open access. These are like a lot of open access journals are there. So you can, I think, you just go to these sites, do a typical Google Scholar search and figure out MDPI journal for that or an IEEE journal for that, and then directly go on IEEE and MDPI and search for that particular resource. And all those research papers would typically give you the mathematical model, the code, not so often, but yeah, very often. But most importantly, the methodology will be there. So I think that's the way you go about it. And we'll definitely share one, good amount of resources on these sessions. So Anjani, you can I think talk about the resources that we'll be sharing. But at a very high level, all that I have spoken, is not really abstract. How to do this is there in the cheat sheets, is it is there in the self-paced guides, and it is there in the video resources that we'll be sharing post this session.
And
So
yeah, so that will be there with the link that I shared initially, which is like the link for this course, where the recording and the content will be live there. Um, we ideally used to give free certificates before, but with the time, like we also have to maintain engagement and other things. So there are some it's still free. There are some admin charges for few of the items, but most of them are free. You can go and see which of the item is free and which of the item is paid. But it's not paid. I would say it's more like some processing charge which you have kept just for the sanity purpose. Uh, so any queries, guide? You are most welcome
Yeah,
to.
I think there is a query from Praval.
Yeah.
He has started his career in data analytics and recently joined an executive course with IIM Rohtak. Please suggest further opportunities I'll have with that course. So, Praval, first of all, I think you've taken a right step to understand and get into the field of data analytics. I do not know the course contents that you do have, but I think to start with, just focus on supervised learning and the unsupervised learning algorithms. Get your basics done, and once you are through it, then probably in one of the areas you build a scientific computing skill. Just catch either of the area, master two or three libraries. That is enough for a good head start.
And I would like to add that on Sunday, most of the Sundays, we have someone expert coming from the industry, across the industry, and they give session. Many of the sessions, certificate and everything is free. And in many of the session, like most of the contents are free. Like anyway, the session would always be free on our Saturday and Sunday session, and those will give you a width as Bhaskar was talking about. And then it will not just it will not confuse you, but in fact it will give you a width around the areas which are actually prevalent in the market and where people are working on, and which is more usable in the industry. And those people who come here are mostly they are engaged with the client, they are engaged with the business, and they are either managing a big set of business in terms of engineering practice, or they themselves are engineering leaders and technologists, expert and researcher. So that will also give a width around different uh, areas around data engineering that will help you out. And from there,
Arun, I has a question. Will you share this presentation? Yeah, I think you just need to go on the fifth IR link that
I've pinged. Yeah,
Anjali
I've
has
pinged.
provided,
Yeah.
um, and you'll be able to download the resources.
All the resources will be there, and it's sorry, you just have to register there, and anytime in the future also, you will get an email after once you register. You will be able to get your resources from there.
Correct. Yeah. Is that it, guys? Do you have any other questions?
Which data engineering tool is good, Pankaj?
Which data engineering tool is good?
Yeah.
Uh, See, data engineering itself is, very vague term. It constitutes of lot of technologies and lot of things. If you are talking about ETL, then I think there is a huge Microsoft stack, which obviously Anjani specializes in, and he's the data engineering guy. But the basic skill set is ETL, where you need to be aware of concepts of
Yeah.
data lake and the cloud. How do you move the data? At least the basic extraction, transformation, and loading concepts. This is
Yeah, that
something
should
which
be like cataloging and how the warehouse being built, how the data is. Obviously, it starts with SQL. So there are a lot of SQL
correct.
topics and SQL courses on our platform.
SQL is the gateway. That's
SQL
right.
SQL is the basic gateway, and then
I
obviously
think for
you guys
even for
have.
every data scientist, SQL is a must-have.
Yeah, SQL is a must-have because most of the even for the big data platform, um, SQL has been layered at the top. And now the way Snowflake is evolving, Snowflake is one of the next gen tool that needed to be learned with. And then, as I said, like you try to, you can go on our LinkedIn site, and as I said, there is a text-based ETL tool class by Billion Mon. He's the biggest person in the data warehouse world, Billion Mon. So he's giving a free course. Depends upon how early you register and how early you get to get a chance, and depends upon him how he select. And we are not sure, but Obviously, we are providing a platform where you can go and apply for that free course, and then you can that will happen mostly in the late evening, 10:30, around 10:30 to 11:30 p.m. You guys can listen him, hear him, and try to understand it, because the another most important thing in the data world, which is going to be a challenging thing to deal with, is the unstructured data. Processing unstructured data is obviously any weight of it.
Correct. All right, guys. I think if there is nothing else, then we'll take your leave. And Anjani, thanks for giving this opportunity. And
Yeah.
obviously, it was difficult to, take time, but yeah,
Thank you. Thanks a
finally
lot,
it
Bhaskar.
happened.
Yeah. Thanks everyone for joining today. And anytime you can connect with us, and on the site is always the link is there. You can connect. Thank you, everyone. Bye.
Yeah, Praval, I think you can connect with us. We'll just share the details on the email. Thank you.
Thank you. There is a Telegram link also, right? So we can connect through the
Yep,
Telegram.
yep.
Yeah. So you go on the fifthir.com. There are multiple links, channels, community to connect with. You just explore the Fifth IR homepage, and yeah, so you will be have a lot of things to connect with fifthir.com. I believe most of the people know until now, but anyway, I've pinned up the link. And there is very easy search. You just need to search with Bhaskar, you need to search with Anjani, you need to search with AI, you need to search with data science. Anything you search, if there will be a course association, it will come up. Thank you, guys. Thank you for your time.
Right.
Thank
Thanks,
you, Bhaskar.
everyone.
Bye.
Bye bye. Good night
Bye.
and good day.